Good day everybody, my name is Carissa. Today, we will be presenting about material selections and sustainability. My team, me and Amelia, we choose badminton racket as the chosen product for our project today. Badminton racket is one of the key tools in sports. It represents a harmonious blend of engineering and athleticism which serves as an indispensable tool for players that seeks precision and powers on the court. Together we will navigate the diverse landscape of material underpinning this essential sporting instrument. So, my team, we choose three materials for our badminton racket. First is the wooden badminton racket, next is graphite badminton racket, and lastly is carbon fiber badminton racket. Let's dive into the engineering behind the traditional wooden badminton racket. Historically, wooden racket can boast a high density profile, which influencing their moment of inertia and swing dynamic, which makes it heavy. But despite their mass, wood exhibit a commendable modulus of elasticity, which will facilitate an efficient energy transfer during shot, thereby enhance control and power delivery. And with greater modulus of elasticity means greater stiffness. With a tensile strength ranging about 90 to 140 megapascal, wooden racket demonstrate resilience against tensile forces. Additionally, their high damping coefficient mitigate vibrational energy, which will ensure play comfort by minimizing hand fatigue. And notably, wooden rackets showcase remarkable creep resistance, which will remain their structural integrity over prolonged use. Next, let's analyze the engineering marvel of graphite badminton racket. It's celebrated for their superior performance metrics. Graphite racket categorized by their low mass, optimize player agility and minimize inertia, thereby it will reduce energy expenditure during swing. With a robust flexural modulus, this racket exhibit exceptional bending resistance, ensuring durability, which means it will prevent from plastically deformation to happen, and responsiveness under varying tools. Enhanced by a high tensile strength, graphite racket endure substantial stress, deliver consistency of performance over time. Their specific modulus ensure a balance between stiffness and weight, which means maximizing their performance efficiency. Additionally, graphite racket excel in absorbing and redistributing kinetic energy, which make them ideal for aggressive playing style. Lastly, let's dissect the engineering prowess of carbon fiber badminton racket. Exemplifying cutting-edge material science, carbon fiber racket boasts an unparalleled creep resistance, maintaining structural integrity under cyclic loading conditions, which will for sure ensure longevity and reliability. Their lightweight composition minimizes inertia, which will optimize player maneuverability and facilitate rapid swing speed. With an exceptional corrosion resistance, carbon fiber racket thrive in various environmental conditions, which making them versatile for various playing environments. Engineered for a resilience, this racket withstand impact forces without yielding or deformation, ensuring a consistent performance under demanding circumstances. And it is also notably for their high intermodular shear strength, which ILSS guarantee an interlayer adhesions, preventing delaminations and ensuring structural robustness. That is all for me. Next, I hand it to Amelia. Thank you.
Hello, my name is Emilia. Now I will be explaining about the comparison, sustainability, and the conclusion. So, for the comparison, we can see there's a few key materials that we have to focus on. First is weight. So for wood material, it is a bit on the heavy side. It is heavyweight because it has high density. So this will increase the power of the badminton racket but make it more difficult for movement by the user. For graphite and carbon fiber, they are lightweight as they have low density, and this is preferable so that they can increase speed and make it easier for them to use and wield the badminton racket. For strength, all three materials have high tensile strength, meaning that it can withstand high amounts of stress without fracturing. So this is a very good feature. For creep resistance, both wood and carbon fiber material have high creep resistance, meaning that the material will deform slower over a longer period of time. So that means that it can be used for a longer period of time. For graphite, however, it has low creep resistance, so this will mean that it can only be used for a short period of time compared to the other two alternative materials. For stiffness, all three materials have high stiffness. For wood, it is stiff and it can absorb vibrational energy. For graphite and carbon fiber, they are stiff and they are lightweight, meaning that all three of these materials have increased accuracy and an adequate amount of power by usage of the user. So for longevity, all three of these materials are made to be long-lasting and used for years. For wood, however, it might be vulnerable to damages such as moisture damage and insect infestation, for example, attacked by termites. For graphite, it has high longevity due to its high impact resistance, which means that it can withstand high amounts of stress without degrading. For carbon fiber, it has high longevity due to its high interlaminar shear strength, meaning that the plates of the material do not corrode each other, making it longer lasting. Based off of these comparisons, we can see that the most preferable material to be used is the carbon fiber. This is because of its high strength and long-lasting properties. For sustainability, we will first discuss the four relevant issues, which is recycling, carbon emission, transportation, and economic impact. For recycling, data has shown that recycling and reusing carbon fibers is an efficient method to reduce the amount of carbon fiber waste accumulation, primarily in landfills. Characteristics such as the length and the environmental impact will be changed after recycling. Overall, recycling carbon fiber material can reduce its environmental impact. Secondly is the carbon emissions. So, carbon fiber is made out of a non-renewable organic polymer source. During the combustion process, greenhouse gases such as carbon emissions will be released to the atmosphere. For transportation, higher demands of carbon fiber will lead to a higher demand from transportation. This will eventually lead to an increase in global warming percentages, as it is similar to the incineration process of releasing greenhouse gases towards the atmosphere. Lastly is economic impact. So, the current resource to make carbon fiber is very expensive and difficult to manufacture. Therefore, a suggestion for improvement is to use a plant-based resource called lignin to create the carbon fiber. This has better environmental and economic impact as it can reduce the manufacture cost by half. Moving on to sustainability, carbon fiber is the most sustainable material out of the three options. This is because it has a low environmental impact and can be used for a long time. For wood, it requires deforestation. And for graphite, it requires mining of carbons and deforestation. Both of these options do not have a good environmental impact. To conclude, a good badminton racket has to be lightweight, easy to use for the user, sustainable for the future, and withstand high amounts of stress. Our chosen material, which is carbon fiber, is lightweight, has high tensile strength, high creep resistance, high toughness, and is long-lasting. So all the materials do check the requirements of a good badminton racket. That is all from us. Thank you for your time.